In this video, I'm going to talk about the principle of mathematical induction, which is very useful if you want to prove statements which is indexed by natural numbers. The principle of mathematical induction requires that we have a sequence of statements indexed by the natural numbers. So for instance, something like this: for all n, natural number n, the sum of I goes from 1 to n, is half n, n plus 1. Actually, there's a very nice proof for this using the trick by Gauss, but I'm not going to talk about that in this video. That's actually one of my favorite Gauss's story, is how he added 1 to, I believe it's 100, in matter of seconds. Basically, he has a very nice trick, and that trick is actually can be generalized to any natural number n. Okay, but we're going to prove this by induction after we introduce what is the principle of mathematical induction. So it works as follows. We have a collection of statements an with n a natural number. We show that the base case a1 is true, and then that's the base case, and then we do the inductive step. What is that? We assume that ak is true for some k. This is called the inductive hypothesis. And then we're going to show that ak plus 1 is true. So the next statement is true when we assume that the previous one is true. So it actually works like dominoes. Okay, so suppose you have all these nicely lined up, right? Let's say this one is k, this one is k plus 1. So the idea is if k is true, then k plus 1 is true. Sort of like when this one falls, it's gonna hit the next one, and gonna hit the next one, and so on and so forth, right? But the only time this guy is gonna fall is when we have an initial push, right? So if somebody pushed this from the beginning, right, it's gonna start the first one to topple, and gonna hit the next one, hit the next one, hit the next one, and everything's gonna fall, right? So that hitting, the fact that one piece hit the next piece is this inductive step, and this initial push is your base case. Okay, so after an initial push, you have all of this dominoes sort of all falling to the end. Okay, so let's repeat that one more time. We show that a1 is true, assume that ak is true for some k, and then we're going to show that ak plus 1 is true. We're going to demonstrate with an example. So it is exactly the statement that we had earlier. Okay, so when you are a beginner in proving with mathematical induction, it's probably useful to actually write down what this statement an is, right? Okay, so let an be the statement that some I from 1 to n of I is equal to half n, n plus 1, where n is a natural number. Okay, so now we're going to show the base case, and then we're going to show the inductive step. Okay, so the base case is a1. Now let's look at a1. So what is a1? a1 is basically sum of I goes from 1 to 1. So it actually only has one term, which is 1. And what we want to show is that it's equal to half times n is 1, multiply with n plus 1, right? So this is indeed true, right? Because half times 1 plus 1, which is 2, right, is equal to 1, right? So the first statement is true. I mean, a1 is true, right? So we have that a1, which is 1, is equal to half times 1 plus 1, right? This is 1 plus 1. Okay, n is equal to 1 here. Now we're going to assume the inductive hypothesis. Namely what? That some I goes from 1 to k is equal to half times k plus 1 for some k in n. Okay, we assume our inductive hypothesis. Okay, now we're going to check if ak plus 1 is true or not. Okay, so let's see. What is ak plus 1? ak plus 1, the left-hand side, is sum of I goes from 1 to k plus 1, right? But you can rewrite this as sum of I from 1 to k of I plus k plus 1, right? This is the same. This is summing summing 1 plus 2 plus 3 all the way to k plus 1. We can write it as add everything up to k and then k plus 1, right? And we know this from our inductive hypothesis, so I'm just going to give inductive hypothesis, which I abbreviated as IH, as my reasoning here, that we already assume that this is equal to half times k plus 1, plus k plus 1, right? So we have that guy is equal to this from our inductive hypothesis, and this remain as is. And then what I'm going to do is I'm going to take k plus 1, factorize it out, and I have half k plus 1. Right. And then what? Well, I want actually half out, right? Remember what we want to show. We want to show that this is equal to half times k plus 1 times k plus 1 plus 1, which is k plus 2, right? That's what we want to show. All right. So half times k plus 1, if we take half out of here, what do we have left? We have k from the first one and 2 from the second one, right? So this shows that ak plus 1 is true. So by the principle of mathematical induction, which I abbreviated as p.m.I, ak, or rather an, is true for all n in n, right? And we are done with the proof. Okay, so that is how we use the principle of mathematical induction. And again, I would like to remind you, the easiest way to remember the principle of mathematical induction is think of dominoes. All right, I'll see you in the next video.